be some period of time. So in Ethereum, it's 15 seconds. So at the period of 15 seconds, multiple transactions can happen. All those transactions will be in the transaction pool. So those transaction pools transactions are listed here. And on top of it, while creating a block, these block headers and additional parameters are inserted into it. So now let's examine the block header because it has some additional parameters, 3 different additional parameters and also some additional items. We'll comment on those. Parent hash is something like it's your previous link. So as it's a blockchain and also it is referring to the previous link. So all transactions will be linked together to form a chain. So we to track what is its previous parent, we have a default entry parent hash as we have previously, and nonce value we have it's positive +1. When it starts at initial transaction, it's +1. So let's say if I have a transaction list of 16 numbers, so my nonce value will be 16. As my transaction list is having 16 value, so my nonce value is updated accordingly. And timestamp is the block's timestamp when it is created. Let me talk about Omer's list later uh, at the end of this module. And we also have kind of beneficiary. So beneficiary is the destination address. And also we have logs associated to it. Logs in where we will be tracking something like receipt or who is the sender I mean who is the receiver that's going to receive my transaction, and also who is the sender, because these blocks will be propagated to multiple network. So the network should know who is the sender. So the logs will also have who is the sender here, and it also has additional values like what is its balance. So the logs itself has what is its gas balance and what is its additional reward balance. So logs is like additional parameter wherein you can examine if in case of any threat or any mismatch, because logs will be available centralized. So in addition to the logs, logs will be pushed to the centralized repo. So if you want to examine logs and find if anything is missing or if you want to match them, you can see the logs. As we have here also, there is a difficulty condition, but the difficulty condition is ruled out when we propose the proof of stake. But with the traditional architecture, proof of work, difficulty comes here, difficulty parameter. But in the Ethereum 2.0, which is a project that is going live, still many rules and regulations are formulating. They kind of eliminated this difficulty parameter, and it's completely based on validation. So no mining will happen there. So, but as an initial parameter to discuss here, difficulty is one of the parameter. It also has something like additional data. If we can put it there, and what is its gas limit, total number of gas limit it has, and what is its gas used for this block. So the node may have a gas limit for 50,000 or 5 lakh gas, but for creating this block successfully, it might have spent some CPU cycles or GPU cycles. So that particular gas used will be also part of the block's header. So here we have 3 kinds of ropes. Earlier, in our old Bitcoin blockchain network, we have something like only transaction root. So we will be hashing all those transactions here. So here we are having list of transactions, right? So all transactions are hashed together and together to form a Merkle root, which is a transaction root. So here, in addition to that, we also do a payload aggregation, and we also do a receipts aggregation. Receipts will be what is receipt is when you send a particular transaction to node from node A to node B. Node B will be accepting the transaction, and post accepting that, it will be sending a receipt to node A, saying like, hey, this is your remaining gas that is unspent. You can use in your further transaction. So that is a receipt that is sent back to node. Sender node. So now you may aware like what is the block anatomy of Ethereum. So just like similar to Bitcoin blockchain, Ethereum have some additional parameters like gas used component, and we are going to see why that is being introduced and why we have such complex block, and how we are going to eliminate the difficulty in our block. So I would also like to quote about this Omer list as well here. Omer list is let's say a particular three different blocks are parallelly trying out to create a block. So uh, I don't have a proper analogy here. Let, let me see if I have any more number of notes. Okay, I don't have notes. Fine. So let me explain this way. So consider we have three different nodes ABC. So all these ABC nodes are trying to create a block, and it's trying to find a difficulty value, and it's trying to create the block and successfully get the reward. So all these three nodes are trying. So out of that, one node succeeded, and it's a first successor. I mean, first person to accomplish that difficulty condition. So that will be formed as a block, and that is added. So in addition to that, the other two nodes, they have spent some CPU cycles, but they are not been rewarded. Let's say they also find that um, transaction. I mean, find that difficulty condition, but it is somewhat late, or it's nearly real time. It's not very late. Uh, some few microseconds after it, I also find out. So we don't want to just like that say, hey, you didn't find that first, so I won't be rewarding you. So instead, depending upon the uh, list, or depending upon the rank at which the nodes find out. Let's say the node B finds out next and node C find out the third one. So depending upon that, the small units of ethers like ways are given to them as well. And those nodes are added to Omer list, and they are called as uncles. So the Omer list is a address of another nodes that were able to successfully identify the difficulty condition, but they were a bit late. So those were added to the Omer list. So you may ask, like, why we need to do this? Why Omer list is there? So what is the benefit that we are getting? One benefit to the users is they have spent some cycles of time. They should be rewarded at least. So a small rewarding scheme can be used to just encourage them for doing further mining. So that is one reason. And another reason is, if my parent block is damaged, using this uncle block also will be pointing to the previous transaction, right? So that they might have also found the proper value. So if my parent block is damaged, I can still go and see my uncles. They will be helping them and they will be defending us. Hey, even though if you disturb parent node, we are there. So we as uncles, we come there and we say, like, the node is damaged and the data is improper. So just have a relook. Um, so we have this option because of this Omer list. So as other nodes also find out, so this makes the linkage very strong. Even though if the parent block is altered, it is not actually possible. But sometimes if it is altered, the uncles will be coming to rescue and saying, like, this is the old value and this is the modified value. We are these many uncles. So just see, like, what is happening at the back end. So this is the block anatomy that we have. Okay. So as I have earlier said, before doing the execution of a transaction, it should do some pre-checks. If they didn't do the pre-checks properly, they might have lose their ethers, or they might have lose their gas points. So these are the checks that have been done before it should be in a proper format. Say like the transaction should have proper who is the sender, who is the receiver, what is the amount he is intended to give, and what is its initial gas cycles. So what is the estimated amount of gas points it will be having. So that format should be proper. It should also be signed by the sender. Sender's public key. Using the sender's public key, it should be signing that, and it should be sending flooding to the other nodes to reach the final node. And we also see like the nonce of the transaction is equal to the count of transaction that sends from the sender account. As I said earlier, to form a block in between the 15 seconds of time, if we have like 7 or 8 transactions aggregated, the nonce value will be updated as 7. So that should be proper. And we also have to foresee what are the intrinsic gas operations. So we foresee these will be the gas operations that will be taken care, and we should set the gas limit, and the gas limit should be greater than or equal to the intrinsic gas operation. Then only it can apply, it can go for the transaction. So, and also one more thing is, if it foresees that intrinsic gas operations is having more, and he don't have enough upfront gas with him, better don't do transactions. Otherwise, you might lose whatever gas or ethers you have, it might be lost. So these are the pre-checks. Now, during the transactions, what happened? Let's see on that one. So when the transaction starts, so first it will detect the gas cost. So the gas cost is something, but is nothing but it's a product of gas and ethers. So that will be deducted first, and as part of the actual transaction execution, the nonce value will be incremented by 1. And it also keep track of the states, like if you have any inactive states. Let's say if you have something like um, post doing this transaction, I need to destroy my contract. Or if you set some rules, those rules has to be set on the process. You should also maintain the log, and the refund amount is also be properly tracked. The refund amount is nothing but the refund gas. So if you spend some 250 gas cycles and you have 50 gas cycles, that refund amount should also be tracked part of the transaction itself. Then only the transaction can the transaction refund amount it can look up, and it can construct the block when it is constructing a block, because block is nothing but group of transactions, right? So each transaction should will have the refund amount what it have. It should be properly balanced. So all these has to be checked, and then the operation happens. What is that operation? So this is the operation. So the spending of gas cycles happen. Okay. Then it finds like if it is having some balance gas or it is out of gas. So if it is having unused gas, send the refund, or if it is having out of gas, reject the transaction. So this is the execution of transaction. So now we are done with the transactions. So we are done with the one transaction. Let's say we have completed 8 or say 9 transactions. Now we are ready to form a block. So the block creation is the mining process where all nodes will compete together to form a block. So here it is something bit different compared to the Bitcoin blockchain. It is IO intensive. So how we can say it is IO intensive and it is not memory intensive is, in Bitcoin network, if you have a mining pool and the mining pool is capable to spin up lots and lots of compute to it, and it can able to achieve its process, so it can form a block successfully, right? So that is possible if it is memory intensive, but here it is IO intensive. So by making this IO intensive, it is giving the chance to all miners. So we don't have any miners left. So if we have like 15 or 16 miners working parallelly, so So it is giving chance to all miners, irrespective of whatever
Sir,
compute it
someone is
holds.
producing a noise. Someone
Hello.
is producing a noise.
Uh, can you please mute that? I think
So Saranya Jyoti.
yeah, Saranya Jyoti, can you please mute up your, or let me see, I can mute. I don't have the option to mute. Maybe host can. Okay, thank you, ma'am. So just a second, maybe. So is my screen visible? Again, you are presenting fine. Then you are presenting. So is my screen visible, guys?
Yes, sir.
Okay, fine. So now we are into the mining process. So let me reiterate. So here it is IO intensive, not memory intensive. We'll see like how it is IO intensive. So whenever a particular block is created, it is associating with an additional parameter, that is directed acyclic graph file. So this directed acyclic graph file is very large file. So it can go up to 3 GB. So whichever node that can able to hold that DAG file into its memory, only those can able to do mining. So that is how it is set. Also for every mining to take place, it takes in an average 15 seconds. Unlike in Bitcoin, you have 4 minutes to form one block, but here it is tremendously improved, and it's just 15 saying just a matter of 15 seconds. The mining takes place, and accordingly the difficulty condition is also relaxed here. So I'll say like why this is not memory intensive, because most of the operations here are IO based, because you need to form that IO. I mean you need to do the IO operation as well, so that directed acyclic graph should be additionally sent along with the block. Let me explain this way. So whenever a new node join the network, so it will get block in addition with the directed acyclic graph. So if it can't able to fit that directed acyclic graph file into its memory, then it itself means that it can't able to do any mining operation. So from that network, it can go off. So it may find some other network where the directed acyclic graph fits for him. So why this is because we want to identify who are the most transacting guys, or who are the least transacting guys, or we can segregate like the person who is having huge amount of money and less amount of money. So we can form different networks, and we can allow only the parties in between there. So it is unfair like in the network, both Bill Gates and me sitting on the same network, obviously he will be winning. He have lots and lots of compute power. So to uh, to have some fair understanding and to have some fair ethics, so the file that has the DAG, the directed acyclic graph, if it can able to fit inside that memory, so only that particular if that file is able to load it inside the memory, then only the node is actually accepting the network invite. And we also see like for every epoch, it is equivalent to 30,000 blocks. Let's say I'm into the network and I'm started doing blocks. Started creating blocks, and my block size is 30,000 block size. My blockchain has 30,000 blocks. That means uh, I have completed my complete one epoch. So whatever DAG file that I have, it will be increasing 72%. So I can be in the same network, or I can move to different network. It's up to my own wish. I will decide like when you want to move to other network, or when you want to switch your direction. So to give a fair trading to all miners, this kind of things were introduced. So hope you are clear with the mining process. Uh, Let me highlight the pointers. So one epoch is 30,000 blocks. When I reach 30,000 blocks, I'll increase my DAG size. So if I increase the DAG size, then again, if new node comes in, that huge amount of file should be able to load into its memory. If it can't able to load into its memory, then the network itself, it can't able to do any mining process. It can do some other validation process, or it can go off from the network. Okay. Let me also put here one real-time use case. In blockchain networks, we in our current world, I mean the ecosystem or the things what we have, they claim that 5 miner pools we have. So if they join that 5 miner pools, no person can get any ethers or any bitcoins into their account. So that is how the system is. If that 5 different mining pools form or inside that network, any network cannot, I mean any network or however compute to invest, you can't able to overcome them, because they will be having farms and farms of, I mean like acres and acres of compute associated to them. If they come and join in the network, you cannot win. So it's not a win-win situation, it's win only situation for them. So that's why like these kind of process were introduced. Okay. So some of the general terms before we move further. There is something like soft fork and hard fork. I earlier said that same at the same time they can able to create blocks. Multiple nodes can create blocks at the same time, because they might be a little bit delay or in some microseconds delay. So they will be having their own version of blockchain. Let's say node A will be having its own version of blockchain, and node B will be having with its own version of blockchain. But as a user, when I joined as a new user, what I will be knowing. So if you have the same transaction uh, happening from the two different nodes and the two different blocks are there, which particular fork I will be switching. So I will not be knowing that. So but they say like the fork that has longest chain will be considered as a default. So this is same case as we discussed in Bitcoin network as well. So any particular node that is having many number of blocks together, it is having like 10 different blocks chained together. But the same scenario, the other node may have 4 different blocks chained together. The priority will be obviously 10 different blockchains that are clubbed together. We assume that it is the predecessor, so we should give more weightage and it should be true, because at that particular period of time, no other networks have find out that this is wrong and reported that. So then that's why it have grown this level. So we say like uh, that is legitimate. So now you understood the soft fork thing. Soft fork is nothing but at a particular period of time, a node can have two different forks associated to it. Sorry, don't not have a single node. At a particular period of time, two different nodes will be having its own blockchain. So that is soft fork. Hard fork is nothing but it's a kind of intentional push. So it divides the blockchain into multiple separate chains, and sometimes both chains can be used. Let's say we have two different parties, both are performing equally good. So then, what is the use? I mean, like if we say like we have two different frequency of blockchains, we can select with higher number of frequency blockchain. But some of the nodes can have same or equal number of forks, or sometimes even the malicious nodes will be intentionally inserting more number of blocks or creating more number of blocks. We know that in a particular network, only limited groups will be there, and those will be like it will not be. It will be following a fair trade policy, but still there are chances that even though if you are using CPU, a particular node may have more experience or exposure, it may do better than other one, so it may lead to a hard fork. So such situation has to be identified and eliminated. So there are many techniques have been found to identify the hard fork. Still, it's in research. So many people can't able to identify the hard fork scenario. So many rules and regulations were put stringent, as like introducing like we should have in a network. It should have a fair trade policy. So that is the main intent they have, and that will be eliminate the hard fork simultaneously if it is employed properly. Now let's move on to the another term, altcoins versus token. So altcoins is nothing but ethers. So if any physical currency or if any currency you can able to buy as and you can keep it as your keep it in your wallet, that is altcoins. Tokens is nothing but you can't keep that as a money. Instead, you can have that as a placeholder. How I can explain for you is consider token as an Amazon voucher or Flipkart voucher. So if you have the Amazon voucher, it's not actual money. You can use that Amazon voucher only onto the Amazon site. Similarly, if you can use that Flipkart voucher only onto the Flipkart site. So how we can correlate with our use case? So tokens are nothing but those are currencies or placeholders that are used for the specific apps. So let's say if you have some smart contracts to execute, so that for doing that smart contract or a smart contract to smart contract application. So let me go back and show you. So here the message system, it says like contract account to another contract account. So for that, you don't need to spend any physical money. Instead, it is spent as a token. See, contract account is not holding by anyone, right? Then how the money will be transferred? If it is transferring from UOA to UOA, some amount he will be sending. Even if he is sending from if the contract has to be established, some amount of money he can spend. But if the contract is triggering another contract, how it will be triggering that? Already the amount is spent on CPU cycles. The contract account will be not having initial amount of money. So for that, every network will be having some group of tokens. So those tokens are values or currencies that are only used by the applications in between. It cannot be used as a physical entity. Like even coins are a digital entity, but what I can say is you cannot claim tokens as money. That's what the difference. So tokens are intended to use only on a particular application or a particular contract. Even tokens can be categorized like a particular token is common for multiple contracts, or a particular token is valid only for a particular contract. So let's say I have a common voucher. That common voucher can be applied to any Amazon subsidies. They have many sites. Let's say if you have many sites, they consider those as 3 different applications. So the common Amazon token can be used for multiple 3 different Amazon subsidiary applications. The other case will be even though if you have the token, the token should have a proper linkage to that particular subsidized location. So even let's say if you have like Amazon, if you have any subsector inside Amazon, so for that you have a wallet inside that. So that wallet will be accessible, and that wallet will be used only for purchasing that. You cannot take out that wallet outside, right? So that is token. So I already said you about the receipt. Receipt is nothing but a sender node is sending a transaction to the receiver node. The receiver node accepts that, and it tracks the remaining gas balance, and it will be sending back to the sender as a receipt. So what additional information it has in addition to the data? The data is nothing but the gas balance that we have. So the receipt also has what is its block number, where the receipt generated, what is its block hash, and some events which are triggered to produce logs. The logs will be like it is having sender address and the payload data. So all those log information will also be captured as a complete receipt, and it will be sent back to the receiver. So with the general terms addressed, let's move on to further section challenge. So we see like many advantages here. So when compared to Bitcoin network, here there is a fair control here. So as Bitcoin, it's execute of for 4 minutes block creation time. Here it's tremendously improved to 15 seconds, and they have 51% attack on multiple attacks since many of the nodes are superior. Here we have grouped them, grouped them logically so that to avoid the challenge. But still, if we invent any technique, there will be some pitfalls associated to it. So let's see those challenges. One thing is its throughput per second is very less. Not compared to blockchain, it is very less. But when compared to other networks like not networks, other payment gateway systems like Visa or Mastercard, they can able to transfer like 21,000 transactions per second. But these Ethereum networks can able to serve less than 2,000 transactions per second. So that is one of the challenges that we have. So if we want to completely remove all our existing payment gateway systems and move to Ethereum, still we can't able to suffice the current transaction limit. So whenever we introduce a new system, we'll be comparing with the existing system and see. So we found that the throughput is somewhat very less when compared to the existing Master or Visa card transactions. Then the cost associated is very high. So in Bitcoins, we don't send any additional fees on top of it, but here we send some fees on top of it, and it makes some costly thing. Even though we are spending very less amount of ethers for giving priority or setting the priority to send your transactions from one node to another node, still the cost incurred is levied, right? So that's why we say the cost is high. So in addition to your transaction amount, for every transaction amount, it is charged. So that is one of the challenge. Then we achieved limited decentralization. So limited decentralization is a positive one, but we have achieved only limited decentralization. So because of this mining nodes, still some of the nodes cycles were wasted, and even though they are given reward, the reward is very minimal if they found it late. So some limited decentralization is there. So if we can able to completely decentralize it, then it is an optimal solution. So that is where Ethereum 2.0 is moving to. They will be removing all miners. Instead, they will be placing validators. So I'll explain shortly that. Now another challenge is the size of the blockchain. So earlier in Bitcoin blockchain, we find that header size is very less and payload is there. But here, if you see the block anatomy, it introduces lots and lots of variables. It is having 3 different routes: storage route, transaction route, and code route. So 3 different routes. It also has gas limit, gas value, then additional information like Homer blocks for the uncle's details. So all this making the blockchain size is very high. So even it might lead to terabytes. Let's say I have like 10,000 blocks grouped together with me. That may even lead to terabytes of size. So when a new node join into the network, the first step is to transfer the existing blockchain to that particular new node, right? So that itself, it is complex. So because of this size complexity, terabytes of data has to be moved when a new node is joined. So that is one of the challenges here. So now we took limited decentralized problem, and we'll observe like how this can be resolved to achieve a future state. So that is Ethereum 2.0. So this project is currently live. It's in the scope of research. So person who is interested in blockchain research, Ethereum 2.0 is the best place to land up here. So here there is no concept like proof of work. Instead, it's proof of stake, where in proof of work miners will be computing multiple expensive calculations, and lots and lots of CPU cycles will be wasted. So that is where in Ethereum also we see. In Ethereum also multiple CPU cycles are wasted, and depending on the cycles, we are giving some rewards. But the next step is proof of stake. I'll explaining what is proof of stake. So it's a kind of betting scheme where all miners will be removed. Instead, validators will be there. So here it has like uh, whenever an Ethereum has to be sent, whenever an Ether has to be sent to the destination node, all four, let's say you have 4 or 5 different nodes, they are parallelly placing a parallelly creating a block. So at that time, it will randomly place a bet. Like I'm just placing my bet as 0.001 ethers and 20,000 cycles. So I just place as a bet. So similarly, other nodes will be also be placing a bet. So by doing this, whichever node that is placing high number of bets, so it will be taken and it will be added as a block. So here it's again it actually resolves the fine mining pool problem. So where the huge number of with a huge number of high CPU cycles availability and GPU cycles availability, they can able to track I mean completely uh, flush the network, and they will be having the supreme control, right? That problem is again reduced. You can ask me that here also, if we go for betting, the miners that is having high ether value. So some of the miners will be having lots and lots of ether values. So that is the node that they will be obviously winning, right? So that's what you will be asking. The problem here is if you do betting once, after betting, whatever you do the betting, that amount will be lost. So you can't place huge bet as well. Let's say if you are transferring an amount from 2 ethers from node A to node B, you cannot place a bet more than 2 ethers. Then it is actually defeating the purpose. So basically, you will be placing the less number of betting, and also the betting will be random. So you may just place 0.001 as your ether betting. Maybe some other node may have done 0.0015. So that will be given the priority. So the users will not be knowing what is the betting amount the other users will be giving, right? So it will be unsure. So validators will be having equal chance of opportunity by this way. So this makes us a random um, choosing of mining. So here the miners, the default miners won't get chance. Let's say if the miner have high compute cycle, it is the one it is going to get always the node. No, not the case. Since validators were introduced and the betting scheme is very random, so randomly all particular nodes in the transactions pool will be benefited. So that's the futuristic scope of Ethereum 2.0. So still many people were saying like there are many pitfalls here we need to address. It's a live problem that is open. Here as well, there is one problem they are foreseeing. Many researchers have came and see like there is a problem called nothing at stake problem. So the nothing at stake problem I have already explained. That is the hard fork problem. As I said, it's a research problem. They are proposing a particular system called Casper. Casper is a solution they are actually proposing. What that Casper will be doing is it will be imposing some penalty. So if the validator is saying like, hey, I am the validator, so some entry fee is actually charged. So whenever a particular node join into the network as a validator, as an initial step, some of the amount of ethers are collected as a initial proof, initial amount. So how you can imagine is when many banks are in place, if any new bank is coming and saying like, I want to start a bank, they will not right away start the bank. Instead, they will get some huge amount of sum that will be centrally maintained. So in case if the bank is behaving abnormally or it is trying to cheat the employee, or if the bank is going in loss, the original amount that is uh, given as a pledge will be taken and it will be distributed among the other nodes, right? So the same thing happens here. So the Casper protocol, what it says is, if a particular malicious node is identified and proved that it is malicious, then it will be removed from the network, and whatever initial sum of amount, sum of ethers it has contributed to the network, that will be taken by the network, and the network can decide whether it can give to the uh, other group of validators or it can keep itself. So still the research is going on, like how it has to be properly managed. So because of this, people will be thinking like, why I want to lose my money by playing not good. So because the initial insured amount is very high, the transactions happening, the entire transactions, if you do 20,000 transactions and get some initial amount of amount, that amount will be equivalent to the initial sum. So that is how they will be setting. So to set the optimal amount of initial sum is also in the research progress. So these kind of items has to be hardly imposed. Mostly Ethereum 2.0 will be applying to again banks. So if the bank is doing some forge, or if it is trying to cheat the employee, or if it is going to cheat the consumers who are using the bank, then certain penalty has to be levied, right? So because of that, these kind of architectures were introduced. So now we are moving to the uh, ending part. So we just have smart contracts left, and we'll be seeing what are some of the applications, and we'll close up the session. So smart contracts. I'll go back and show you there are two different types of transaction accounts. One I said is externally owned account, which is you. It's a physical guy. So you are the one who will be owning the externally owned transaction account. But we should have some proper schema and proper proper structure for the contract account, right? So that's what we are going to see now. Still we didn't see the contract accounts proper application. I just said you one simple application, that is tax calculation. So we can have multiple smart contracts. Smart contracts is nothing but if you have any system in place. Let's say if you are going to do a particular piece of task, and the piece of task has multiple submodules. So that has to be done. Then only you will be granted access if you have such kind of scenario. So those are like pre-checks, or it may be the prerequisites, or to complete a particular process. These are the steps you need to follow. So those can be the smart contracts. How you can relate this? I'll give you another example. So one may be the land registration or lands verification. So when you register a land, you will be following sets of steps, right? So now it is not properly digitized, and even though it is digitized, it is not in a blockchain way. So it has its own limitation. So we are still searching like how we can able to get the proper value, and is the land is valid? Are we getting from the miner? Is the land is having some any problem, or is this a fresh land, or a particular transactions have been already taken place? So we will be verifying the encumbrance certificate, where we'll be seeing the 30 years or 20 years history, and we'll be seeing if there is any forge or something bad has to be happened. We will be by using all these techniques we are seeing. But still, for a common man, if it is trivial. I mean, it's not trivial for a common man to check all these details and make as a proper process. It's a bit tedious task only. Maybe who have exposure to that and bought more land, they might have familiar with the process. But even though if the process is good, many of them are giving black money or transferring the amount in hand. So they will be registering like they will be doing some undervalue registration. Say they will be initially what they will be doing is uh, the land price may be 30 lakhs, but what they will be doing is they will give only 20 lakhs as a account ledger balance, and 10 lakhs they will be getting in hand. So all these things will be captured in blockchain. So you can't escape. So since it's completely derived on blockchain fashion, so all transaction has to be maintained over there. So otherwise, if you got 10 lakhs in your hand, then again it is also tracked. I mean, your account will be given, I mean, flooded with that value. So people may question. So such kind of actions can happen, but still there are wiser ways. What they will be doing is take the 10 lakh, invest in Bitcoin, so that anonymity is maintained. So there are many loopholes, but they are trying to collectively address those fashion. Even though if we go via blockchain, the people are finding multiple loopholes. So government is formulating a proper way that land registration or land verification process is very smooth, and there is no black money exchanges happening. So they are taking some strict care there, and constructing the smart contract is on in the progress. Okay, now let's come back to the smart contract one. So every contract will be having a program where set of values or some checks will be uh, done in the process. So smart contract is one where once it is inserted into a particular node, it will be executed for sure. So it can post execution, it can be deleted, but it cannot be modified, or whatever values that impose that, it cannot be modified. So even though if you delete and recreate one, it is created as a new entry, right? So the deletion will also be tracked, and the creation will also be tracked. So here we guarantee that modification is not happening. So why? Because government policies will be changing frequently, right? So earlier the tax rules were different. Now the tax rules were different. So all these tax rules and things will be appended only, which it will not be modified. So that we can have a track of history, like, so okay, this is how the tax have modified. So if in the last year this is how the tax rules were there, and now the smart contract is modified to impose these new conditions. So like that, whatever, even if you do a minimal change, it will be added as a new entity, and it will be published as a new rule. And smart contract is generally dormant in nature. Dormant in the sense it will be in sleeping state always. So whenever it should be triggered by a particular person. So when you say I want to pay tax, it will not directly take from your wallet and put it in government wallet. So it will ask for your approval as well. So the smart contract will not be executed automatically. So you will be starting that smart contract, and you will be giving the input parameter values, and you will be signing that with your entity, so that you comply to whatever data you are sending to them, whatever initial employment salary or whatever details you publish or furnish that are true to your knowledge. You agree that, and you sign it, and then send as a transaction to the government. The government will execute the smart contract, and then the values will be sent back as a receipt to you. Then you by seeing that receipt, you again initiate a transaction saying like, this is my tax I have been paying. So what it happens is, if you compare with this analogy, so what I am doing is, first I will be doing a value transaction. So I'll be first I will be doing message call transaction. I'll ask my contract to be running, and the contract will be giving you a particular result. So this is my tax or any particular value that I get out of the result, then what I can do is I can do the value transaction. So smart contracts can, if the contract is very big, the contract can call multiple contract. But whenever you are doing a ether based transaction, EOA to EOA happens. Here as well, ether transaction happens, but those were just minimal fees. No actual amount is sent. Here is where the actual amount is sent. Here just fees is sent, not actual amount is sent. Okay. So now let's see how this is developed, how the smart contract they are developing. So they are developing with a language called Solidity. Uh, many projects were available in Git. You can check it out. Other languages like Viper or Serpent are used to develop smart contract. It's a high-level language. It's similar to Java or any language that you see. It's object-oriented. The compiler that you use is Sol-C. So it generates a EVM by input where it's universal and it's a standalone application that runs on your machine. So whenever you install the Ethereum client, this compiler comes handy there. For executing any smart contract, these compilers are very helpful. So to create smart contracts, now popularly used IDEs where Remix is used as an online IDE where you can do all your smart contract creation, deployment, and do all other stuffs through online. We also have a local IDE, Truffle. We have many node package managers, Docker versions available. So you can run it on your local as well as a Docker. So now let's see a sample smart contract. So this is a smart contract that I've created. So you can see there is a Pragma Solidity. The version may be from this to this. What I do is I create a sample contract where I input n as my value and I am returning out as some value. So here you can think of a tax related calculation. So tax value can be coming as an input. Some complex or tedious operations can happen inside, or even it can trigger another contract inside. Then after that, a particular result will be sent as a contract output. So I'll show you the sample contract in browser. So this is the Remix Ether ID, Ether IDE. So you can see here multiple environments available. As to start this Remix Ethereum, you need to install some plugins. So this is my plugin manager, wherein I can have multiple plugins associated on together. But for deploying and running transaction and to compile our transaction, these two are very essential. So I have activated those two plugins. This is my Solidity compiler. So I've enabled auto compile. So whichever I didn't file, I select any file. So if I select any file, it will automatically compile this. So now let me go and select any one of the file. So I created this sample SYL file. So this is what the summation one. So let me introduce some faulty value here. I just put public one. So here it says like an error. So if you go and see in the compiler, it says contract not compiled yet. And it says there is some missing, there is a value is missing. So even if you compile it, it will throw some error. So it says like undeclared function. So you can verify this way. It is interactively showing here, but since I've enabled auto compile, it is showing me there. Otherwise, I need to compile every time and see how it is performing. So yeah, I'll send you the sample contract files that I have for doing a transaction. So even when you just enter into this remix.ethereum.org, you will be given with a gas limit of 30 lakhs as an initial amount. This is for just a training purpose. See, the environment I have is multiple environments. I have JavaScript VM, injected Web3. So these are my different environment that I have. Let's say I use Java VM. and I need to register me as a me, right? So I need to have an account. So they have multiple accounts there, and each account is having 100 ethers. So since I have done some 3 transactions recorded, see, I just done 3 transactions. So my Ethereum value is getting reduced. So it is reduced 99.99 some ethers. So so then you can see like for doing a transaction, that too just deploying or creating a block or doing a small transaction, you can see like it is very less number of ethers that is being spent. So only when you send a value based transaction, many number of ethers will be spent. Just for doing transactions, these are levied as fees. So the fees is very minimal. You can see from here. So also I can set the number of ways in addition as a gas fee. So by default, the network will be deducting some. In addition, I can spend some additional ways on top of it to execute my contract as a priority one. So my sample file I have just explored here. If I just give a deploy, so it start deploying and it will give the result. For now, I think morning it executed and gave me 3 transactions. Now it's failing. Let me do one thing. So I'll just paste this link. You can even try at your browser and see like how the transactions are happening. So these files will be initial files, storage SOL and owner SOL and ballot SOL are by default it's present. You can create your own SOL file and you can write this way and you can compile this one. Let me put that link in the Google Hangouts, but you can try checking that. There is chat. I don't see chat. Okay, here it is. And we'll just explore other presenting to everyone. Okay, now I think hope it is visible. Okay, let us see like other SOL files. See, it's just a storage contract where it is having number. It's just header and setter. Getter and setter it has. I have another owner SOL. So this is like whenever I send any particular transaction, I'll be registering my address. This address will be my acting as my key. And I already said there will be an event will be triggered. Event is nothing but it's a logging. So you will be logging with your old owner and new owner. So where is the transaction happening and where the transaction ended. So that event is also captured. See, you can see here, it says emit owner address of 0,1. So it says like you are sending from your address to the owner address, right? Since the link is there, you can explore more, see how the contracts are created. But the simple way what I can say is to create a contract, it should have a particular input and it should have an output. So the contract will accept a particular sets of inputs and other additional params. It do some complex operations inside and give back as a result. So this contract itself is added as one of the component inside the blockchain so that the contract can be tracked. You can ask like the same is happening outside, but this is happening in a blockchain way. So that you can see what is your initial contract and how it has been changed on progress. Now let's move to the last slide up. So I've covered pretty much all the applications. Let me just reiterate here. So it's we can use this Ethereum network completely for getting or gaining the digital currency. The other applications may be like any process driven culture. So if you have any process that has to be executed, or if you give some input value to the particular system, it do some kind of process, and the process is also changeable nature. The process is not fixed, it changes on time. So if you have such kind of nature, so at that time you can go for Ethereum network. So the land registration and verification process is one of the application. The tax computation is again another application, because like yearly basis, the tax slabs are changing, or sometimes it's not changing. But since it's a changeable phenomenon, it can adapt to Ethereum. And even in supply chain management, to track the complete uh, uh, position from high vendor to the low vendor. So how the particular product is varying, the product price influence across sectors we can able to identify. So these are some of the applications. So hope like as a learning outcome, you might have learned about the applications of Ethereum and basic working of Ethereum, and how we can able to trigger the smart contract. We can trigger the smart contract through the externally owned applications, and the smart contract can itself trigger another contracts, and how the smart contract look like. So all these as part of your learning outcome. I think I'm done with the session. So any questions, team?
Hello, good morning, sir.
Yeah, good morning.
Sir, at the time of execution of your program, you found some error, but you said that in the morning there was no error, but recently you got the error. So why did it happen?
Sorry, I didn't hear your voice properly. Can you repeat again? Hello.
Sir, the program did not execute.
Okay, the program may not execute. Then
You got some error, sir.
I think I'm hearing you in parts. Maybe team can confirm like all others are hearing like that, or it's me. Can you come again, please, sir? Maybe for another, or you can post your question at chat window. Let me look. Have a look. Okay. So you want the demo on Remix? Fine. Just a second. It's taking some bandwidth. See here. So what here you want me to do? Okay, now maybe like you might be asking to explain what is this. So smart contract is this structure. So if you want to kind of compile this, you can do this way. And there is an options to sync your particular smart contract to the Docker Swarm, or you can publish this as a contract. If you just publish it on Swarm, it go and publish it in Swarm, and it will return some metadata. Even it can, Swarm is nothing but your local, or it's a remote particular pool of nodes. IPFS is nothing but an open source community where you can publish your contracts as well. So here as well you can publish. So it published its metadata. So if you go and see here, so you can see like these are my Swarm and these are my IPFS. So one Swarm you can see like your contract itself, and another Swarm it will be the metadata. So since I executed multiple programs, I am getting multiple Swarms. So one may be the which compiler. So it's executed in pairs. So this is the one I executed last. So my contract file is there, and associated compiler version and all other inputs and outputs will be displayed here. Similarly, the case for IPFS. So it have the contract and also what is the output and input and output. And for deployment as well, you can use this value to do deploy, or you can straight away publish to IPFS. So my initial way is 100. So since I use this account, since I done some transactions, my transaction has been, my waste has been reduced. And yeah, for some reasons, my transaction recorded is not happening for now. These are the transactions I done it in my, later a few hours ago. That's why I asked you to try out. I will just send you this link. Maybe I'll be sending some other files as well. You might be using you might have to use the proper version to start this one. Otherwise, it will throw some error like version is mismatching. That is why here we kind of introduced multiple versions tied up together. So if you are not sure like which version you want to use, you can say like it should be greater or equal to and less than, so that your program compiles. Otherwise, it may throw some error. So I will send you some other samples as well. Additionally, post this session, I'll send this PPT along with some SQL files. You can try at your local and see like how the transactions are happening and how the wages are deducted, how the gas values are consumed. Yeah, I think it got resolved, your question.
If the gas
And
value is adjusted, then will it be automatically reloaded, or you have to do something new across?
yeah, see, once you completely exhaust your gas value, you should create. It's a very easy to create another new node instead of recharging it. So once the gas value completely exhaust, try out in another node. So in a practical world also, whenever you start with a node, you'll be initially purchasing some gas value. So post your gas completion, you want to again initiate another node as another node with a new number of gas cycles and gas values.
Okay, thank you.
Yeah, and I think like thanks for your cooperation, because like I have a meeting by 11. So if you have any further more questions, you can drop out to my mail ID. I'll just share my mail ID and my LinkedIn ID to you.